The next sorting algorithm that we will implement is merge sorting algorithm. But as part of the algorithm that we have for merge sorting, one of the steps that we have is merging of the two sorted arrays such that the array will still remain the sorted array even after merging those two sorted arrays into a single array. So let's just try to understand what is the effective way to merge the two sorted arrays such that in the end the merged or the resulted array also remains sorted either in the ascending order or in the descending order based on the way the input arrays that we are getting. Okay, for example, let's just try to assume we have been given two arrays, array 1 and array 2, namely here both the arrays are sorted in the ascending order. So whatever the resulting array that we should get, it should also remain sorted in the ascending order throughout the array. Okay, but remember that here both array 1 and array 2 are sorted in the ascending order. Remember that whatever the arrays that we get as an input, both of them should be either sorted in the ascending order or both of them should be sorted in the descending order. That is something that you have to notice. If one of the arrays is sorted in ascending order and the other array is sorted in descending order, the algorithm that I am going to explain will not work. So that is something that you have to remember. So since both of our arrays that we have got here are sorted in the ascending order, whatever the resulting array that we get after merging these two arrays into a single array, that array should also remain sorted in the ascending order. Okay, as part of the first approach, why don't we create a resulting array whose length is equal to sum of the lengths of both array 1 and array 2. Then we will move all these values from array 1 and array 2 into the resulting array, and after that why don't we apply the sorting technique, right? So far we have seen the bubble sorting algorithm, selection sorting algorithm and insertion sorting algorithm. So whatever the merged array that we get after merging array 1 and array 2 into a resulting array, we can apply the either of these three sorting algorithms such that in the end whatever the resulting array that we are getting will be sorted in the ascending order as well. But the thing is, one of the steps that we use as part of the merge sorting algorithm itself is merging of two sorted arrays, right? That means while implementing one of the sorting algorithm, using the another sorting algorithm doesn't make any sense. That's the reason why we will not be merging those arrays into a resulting array directly, and we will not apply sorting after moving all the values into the resulting array. For that, we have a special way to effective way to merge these two arrays into a sorted array, like I explained right now. Okay, for merging these two sorted arrays into resulting sort array, what as part of the first step, what we will do is we will create the resulting array whose size is equal to the sum of the lengths of both arrays. That means here on the array we have 4 values, and here on the array 2 we have 5 values. That means that in the resulting array basically we will have 9 values. That's the reason why as part of the first step we will create the resulting array whose size is equal to 9. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So the indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now the very first value in the resulting array, whatever we have created, it should be smaller value, right? Because after merging both array 1 and array 2 into the resulting array, whatever the values we have should be remain in the sorted ascending order only, because both the arrays that we have here are sorted in the ascending order. Now to merge these two arrays into resulting array, what we will do is we will basically take the help of two helper variables pointing to the very beginning indexes in each and every array. So here for array 1 I am defining a variable called I, and it is pointing to index 0, and the indexes we have for the array are these 1, 2, 3, 4 are the indexes. For the array 2 we will define one helper variable called j. Here as part of the process what we will do is we will compare the values at ith index from the array 1 with the value at jth index from array 2. That means right now I is equal to 0 and j is equal to 0. Now the value at zeroth index is 1 and the value at jth index in array 2 is 2. Out of these two values, what is the smaller value? 1. So we will move 1 into the resulting array's 0 index, and the next index that we need to fill in the resulting array is 1. Since we moved 1 into resulting array, we will move I to next index. That means we will increment the I from 0 to 1. So I will be pointing to the first index as of now, and j is still at index 0 only because we don't know when the value 2 will go on to the resulting array. That's the reason why j is still pointing to 0. One thing that you have to observe here is, once we move the value from either array 1 or array 2 into the resulting array, we will increment either I or j based on the array that we are using for moving that specific array's value into the resulting array. Since here I have moved the value from 0th index, that means from array 1 I have incremented the I to 1. Okay, right now again the value at ith index from array 1 and jth index from array 2 will get compared. Here 3 and 2 will get compared. Obviously 2 is smaller than 3, right? So we will move this 2 into resulting array, and the next position that we need to fill in the resulting array will be 2. Since we have moved this value 2 which is available at jth index, which is nothing but 0, into the resulting array, we will need to move on to the next index in the array 2. That's why we will increment the j by 1, so j will become 1. So j will be pointing to 4 now. Again I is at 1 and j is at 1. Now we will compare these two values again, 3 and 4. Obviously 3 is smaller value, right? So we will move 3 into the resulting array. So since we have used a1, that means I will be incremented by 1, so it will become 2. Now I will be pointing to 8, j is still pointing to 4. 8 and 4 will get compared. Obviously 4 is smaller than 8, right? That's why we will move 4 into the resulting array. Once we move 4, which is in a2, which we are representing by the value of j, j gets incremented by 1, so the value of j will be becoming 2. Okay, now j will be pointing to 6 and I will be pointing to 8. 8 and 6 both will get compared because they both are available at indexes what we have in the variables I and j. 6 is smaller than 8, right? So we will move 6 into the resulting array, which is at index 4. Now since we moved the j value from index 2, we will increment the j by 1, so it will become 3. After incrementing the j by 1, j value is 3, right? The value we have at index 3 is 10, so j will be pointing to 10 and I is still available at index 2 only. That's the reason why 8 and 10 will compare. Obviously 8 is smaller than 10, right? So we will move value at ith index, which is nothing but the value at second index, which is 8, will be moved into the resulting array. So in the resulting array also 5th position is filled. Next we need to fill the 6th position, and since we have moved value from second index, we will increment the I by 1, so I will be pointing to 3. Now both I and j are available at third index. I is having 11 and j is having 10. 11 and 10 gets compared. Obviously the value 10 is smaller than 11, right? So we will move 10 into the resulting array. Since we used j, we will increment j by 1, so it will become 4. So j will be pointing to 40 and I is still pointing to 11. Now 40 and 11 will basically get compared, and obviously 11 is smaller than 40, right? So we will move 11. As a result, we will increment the I by once again, so I will be pointing to 4. If you observe here, after incrementing the I by 1, the value of I has become 4. That means that we should basically have the index 4 available in the array 1, so that we can compare the respective values that are available at ith index from the array 1 and jth index from the array 2. But here on the array 1, we only have 4 values. That means that the largest index that is possible is 3 only. As a result, that basically represents that we have successfully processed all the values from array 1. So all the values that we have on the array 2, if at all if we had any, we need to move them directly into the resulting array. Why? Anyway, whatever the comparison logic that we are doing, whatever the moving that we are doing from either of A1 and A2, once we complete processing of one of the array, that basically means that whatever the values that we have in the remaining array are obviously larger. That's why we need to move all the values from either of this array into the resulting array once we go beyond length of the array that we have got. So here on the array 1 we have exhausted all the elements, but on the array 2 we still have 40 that needs to be processed. As a result, what we will do is 40 we will be moving into the index 8. Okay, so that is the logic that we follow for merging the two sorted arrays effectively into a resulting sorted array. Okay, so what exactly is the algorithm that we followed for merging the two sorted arrays effectively? We basically created a resulting array whose size is equal to the sum of the lengths both array 1 and array 2. After that, we created two helper variables pointing to very first values we have in the arrays, which are nothing but the values at 0th index. And as we continue, we basically compared the values at ith index and jth index. As a result, based on their nature, we basically moved those values into the resulting array that we have created. Okay, in the process, once we complete processing of either of the arrays, whatever the values we had in the remaining array, we will be moving them directly into the resulting array. For example, let's just assume in the array 2 we had values 50 and 60 also. In that case, the resulting array would have two more elements, and 50 would have moved here and 60 would have moved here, because anyway while comparing the respective values we have already exhausted the all values from the array 1. So obviously whatever the values that we still have in the array 2 will obviously be larger than whatever the values we have filled in the resulting array so far. So we can pick up all those values directly and we can add them into the resulting array directly, because array 2 itself is again sorted in the ascending order. Okay, anyway, let me just give one more example of merging of two sorted arrays such that you will have even more clarity. For example, in the beginning, let's just assume the array 1 that I have got has values -4, let's just say 0, 2, 4, and the array 2 that I have got has the values -2, 10, 30 and 50. Okay, now we need to merge array 1 and array 2 in such a way that since both of them are sorted in the ascending order, the resulting array also should be sorted in the ascending order only. So for that, anyway in the array 1 we have 4 values and in the array 2 also we have 4 values. As a result, we will basically create a resulting array which has 8 values: 1, 2, 3, 4, 5, 6, 7 and 8. Okay, indexes are 0, 1, 2, 3, 4, 5, 6 and 7. So in the beginning, 0, 1, 2, 3 are the indexes for array 1, 0, 1, 2, 3 are the indexes for array 2. So in the beginning, I will define one variable I, initialize it with 0. So I will be pointing in the array 1, and I will define one more variable j, and I will also initialize it with 0. So j will be pointing to 0th index. Now the value that needs to be filled in the resulting array is 0th index. So that also we will keep track in some other variables so that we can directly fill that value either from array 1 or array 2 into the resulting array that we have created. Now the value at ith index and jth index are basically available at 0th index that we need to compare. So -4 and -2 we will compare. Obviously -4 is smaller than -2, right? So we will move -4 into 0th index. So -4 will be moved into 0th index. So we will increment I by 1. So I will be pointing to first index and j is still available at 0th index. Now what we will do, 0 and -2 will get compared. Obviously -2 is smaller than 0, right? So we will move -2 into index 1. So -2 will be filled. The next position that we need to fill is 2. And since we have moved the value at jth index from array 2, we will increment it by 1, so j will also be becoming 1. Now j will be having a value 10. 10 and 0 will get compared. Obviously 0 is smaller than 10, right? So we will move 0 into the resulting array into position 2. Now the next position that we need to fill is 3. Since we have used the value from array 1, which is nothing but ith index is having that value, right? So we will increment it by once again 1. So I will be pointing to the index 2. J is pointing to 1. So 2 and 10 will get compared. Obviously 2 is smaller than 10, right? So 2 we will move it onto resulting array. So since we have moved 2, I we will increment. So I will be pointing to the index 3. Now j is pointing to index 1. 10 and 4 will basically get compared. Obviously 4 is smaller than 10, right? So we will move 4 into index 4. Okay, so the next position that we need to fill is 5. Here, as we move the value 3 into index 1, right? So we will increment the I by 1. So I value will become 4. But the thing is, we have moved all the values which are nothing but till the index 3 into the resulting array. There is no index 4 such that we can compare the ith value from array 1 and jth value from array 2 so that we can move either of them into the resulting array. Basically, we have moved all the values from array 1 into the resulting array. So the only values that needs to be moved are available in array 2 only. That's why what we will do is we will immediately move one by one value directly into the resulting array. Since anyway the array 2 is also sorted in the ascending order, we don't have to worry anything. We can simply copy all the values directly. So we have moved these three values into resulting array. So one thing that you have to notice here is I have exhausted all the values from array 1, so I have run the loop on array 2 to copy all the values into the resulting array. But the other way could also happen. That means that as part of the previous processes, we could have exhausted all the values in the array 2, but we may still have some more elements that need to be processed in the array 1. So if at all if that is required, we need to move all the values from array 1 to resulting array as well. So that is the step-by-step process that we follow, such that whatever the sorted arrays that we get, in the end the resulting array will also remain sorted effectively. Okay, now that we know this step-by-step process, let's just go ahead and let's just try to write the pseudocode of this implementation.